This bird memorizes over 200 songs, and that's the least strange thing about it. A northern mockingbird can sing for 6 continuous hours without repeating itself. 6 hours. The human brain, under laboratory conditions, struggles to retain more than 7 unrelated items in working memory at once. This bird carries entire sonic libraries, improvised, expanded, and deployed with strategic precision. That number alone should stop you. But here is what makes it stranger. The mockingbird is not simply repeating sounds it has memorized. It is doing something no other creature in the animal kingdom does in quite the same way. So what is actually happening? Stay with this, because it changes everything. If what you just heard made you lean forward, this channel is where you belong. Subscribe now, because what follows will permanently change how you hear the bird outside your window and how you think about the minds of animals. This channel exists to follow the research where it leads, past the comfortable explanations and into the biology that most nature documentaries never reach. Everything here is sourced, specific and strange in the best possible way. The first thing most people learn about mockingbirds is that they mimic. The name says it. Mimus polyglottos, many-tongued mimic. Stand near a suburban hedge in spring and you will hear a rapid, looping cascade of songs, calls, and sounds cycling faster than you can identify them. What the textbooks say is this: the mockingbird copies the songs of other species to expand its repertoire and attract mates. That explanation is true. It is also deeply incomplete. The biological mechanism behind it involves a region of the bird's forebrain called the HVC. The higher vocal center, which in mockingbirds shows unusual plasticity across the adult lifespan. Most songbirds lock their vocal learning into a critical developmental window and close it. The mockingbird never fully closes it. It keeps adding. Stand in a neighborhood in Raleigh, North Carolina or Tucson, Arizona in late April. Listen closely enough and you will hear the mockingbird cycling through the local Avian neighborhood like a DJ who has memorized every track on the block. Cardinal, robin, blue jay, wren, looping each song precisely twice before moving on. Here is where expectation begins to collapse. A 2009 study published in Animal Behavior by researchers Dave Gammon and Andrew Altizer found that mockingbirds incorporate non-biological sounds into their repertoire at measurably higher rates than their rural counterparts. Car alarms, squeaking gates, construction equipment. A cell phone ringtone heard once through an open window can reappear in a male's territorial display weeks later. This is the counterintuitive agent. The city itself is shaping the bird's voice. The urban acoustic environment, loud, quirky, and mechanically percussive, is being selectively filtered and incorporated. Researchers at the University of North Carolina documented individual birds in Chapel Hill whose songs contained at least 11 distinct artificial sound signatures. At 3 a.m. while you were asleep, the male on your street was rehearsing an expanded set, cycling through what sounded like a short circuit in a machinery catalog. The mockingbird does not hear human technology as noise, it hears it as material. Now consider what happens at night, not to the bird's song but to its silence. Across the southeastern United States, ornithologists have documented a phenomenon that sounds almost cinematic in its darkness. Male mockingbirds in their first breeding season, those who've not yet secured mates, will sing through the entire night. Not intermittently, continuously. This is not random. A 2004 study in the AUK, the Journal of the American Ornithological Society, found that unmated males sang significantly more at night than paired males, and that nighttime singing appeared to specifically target females conducting covert mate assessment. The male is performing to an audience he cannot see, in darkness, with no confirmation that anyone is listening. The second scenario compounds this. Rival males have been documented using song as a weapon in territorial displacement. They do not fight, they escalate. One bird increases complexity, the rival matches it. The exchange can last hours, each bird cycling through its deepest catalogue, testing the other's limits. When one bird runs out of novel material, it begins repeating. The moment of repetition is the moment of defeat, and the winner holds the territory without a single physical confrontation. No evidence of the conflict remains in the landscape. The third and darkest scenario involves what researchers call vocal deception. Mockingbirds have been documented mimicking the alarm calls of other species, specifically the sharp, urgent distress notes that cause small birds to freeze, flush, or flee. There is preliminary evidence that some individuals time these calls to clear competitors from food sources. The alarm rings out, the other birds scatter, the mockingbird feeds. No trace remains of the manipulation. What emerges from these three mechanisms, the continuous learning, the territorial vocal combat, the possible strategic deception, is something more complicated than mimicry. These behaviors rarely overlap in a single bird in a single place at a single observable moment. The conditions required to witness any one of them fully are already specific. The conditions required to witness all three converging would be extraordinarily rare, and the evidence they leave behind is almost exclusively acoustic. You would need to be listening at the right time, in the right place, for the right duration. Most people are not. They hear something beautiful and move on. But here is the deeper question, the one that changes the frame entirely. For most of the 20th century, the mimicry of the northern mockingbird was classified as instinctive display behavior. Elaborate, yes, but essentially mechanical. A performance driven by genetics and reinforced by selection pressure, a sophisticated reflex. Then the research began to get uncomfortable. A 2021 study from the Cornell Lab of Ornithology analyzed the sequential structure of mockingbird song, not for content but for syntax, the order in which song types were arranged across long performance bouts. What they found was that the sequences were not random. They were not simply driven by what the bird had most recently heard. They showed internal logic. Transitional probabilities, the likelihood of one song type following another, were consistent across individual birds and appeared to be actively managed. The bird, in other words, was making choices about what came next. The evidence here is precise, and it is also deliberately limited in what it claims. A 2019 paper in PLOS One by Tina Rusk and colleagues, conducted across multiple continents and species including mockingbirds, found that the acoustic sequences of certain mimicking birds showed statistical properties associated with human music, specifically a preference for song transitions that moved in predictable pitch intervals rather than random jumps. This is not metaphor, it is measurable. The birds were navigating acoustic space in ways that correspond to what humans call musical logic. Researchers at the Max Planck Institute for Psycholinguistics have noted that the structural complexity of mockingbird song exceeds what can be explained by simple associative learning. The bird appears to be generating novelty, not just storing and retrieving it. A 2022 behavioral study tracked individual males across breeding seasons and found that each bird's repertoire shifted not by random addition but by selective pruning, removing songs that had proven less effective and retaining those that produced measurable responses in rivals or potential mates. The bird is editing. What this does not prove is equally important. It does not prove self-awareness. It does not prove musical intention in any human sense. It does not establish that the mockingbird experiences its own song the way you experience music. The evidence is for structured choice in acoustic output, not for inner experience. That distinction matters. What remains genuinely unresolved is the question of individual signature. Researchers have not yet established whether mockingbirds recognize each other by the specific composition of their repertoires, whether the unique combination of songs a bird uses functions as something like a personal voice. There is suggestive evidence. There is not yet proof. That door is open and the research is ongoing. So here is what is actually happening. The mockingbird outside your window, the one you have always heard but perhaps never truly listened to, is running a continuously updated acoustic library shaped by its specific urban or rural environment, structured by internal logic that researchers are still working to fully describe and deployed with measurable strategic purpose. The mimicry is real. The complexity behind it is far larger than the word mimicry contains. And then there is the other register, the one that sits beneath the biology. You have spent your life surrounded by a mind that keeps learning, keeps revising, keeps adding to what it knows without ever deciding it knows enough. It has been doing this in your backyard, at midnight, in front of no audience but the dark. There was a bird outside your window that never stopped becoming more than it was. You just did not know what you were hearing. You did not know what you were missing, until now. Have you ever stopped and truly listened to a mockingbird? Not just heard it, but listened? Tell me in the comments. Where were you? What time of day was it? How long did you actually stay and listen? And did you notice it cycling through the same sequence twice? I want to know what you heard. I will read every single one.